Well, good morning everybody. Welcome along. We'll get this webinar started. And so Luke's just joined us. Hi Luke, how you doing? Okay, let's get this started. So I'll just click through into our first. Good morning everybody, and welcome along to this Autodesk Fusion 360 webinar, the Fusion 360 story. My name is Paul Munford, and I'm an application engineer here at Greytech UK. And I wanted to thank you very much for attending the webinar today. I've noticed that a few of you are existing customers. That's fantastic. I'm pleased to have you along. We also have a few people joining us who aren't currently customers, and that's great too. So if there's anything we can do to help you out, just let us know, and I'll give you my contact details at the end. So for those of you who don't know Greytech, we are now an international company. Greytech, the mother company, are the company who made Advanced Steel, and they recently sold that to Autodesk. Greytech UK, an Autodesk reseller. We were originally Address, and we've got 26 offices worldwide, but in the UK we've got these offices: Southampton, Milton Keynes, Nottingham, Bradford and Durham. So we're always somewhere close by, so do come in and say hello. Okay, let's progress with the webinar. So today we're going to cover, we're going to ask the question, what if you could redesign CAD from scratch? What would you like to see in a CAD system? We're going to ask what Fusion is, a fusion of what? We're going to look at how to sign up for Fusion 360, and then we're going to dive in and I'll do a demo and take you through some of those key points that you might be interested in. So we should be here for about 40 minutes, so thank you again for your time. So let's just begin by asking the question, what if you could redesign CAD from scratch? So imagine that you could pick and choose. What would your favorite CAD software look like? What would it do? So what would you keep from your current CAD package? Because it's often said, what's the best CAD package? The best CAD package is the one you know best, right? So the one you've got currently, there will be features that you really like and you'd want to keep. But what would you take from other CAD packages? You may have seen on YouTube, or you may have seen somebody demonstrate some features that you're really interested in, you'd really like to have, you wish you had in your CAD package. Now, what platform would your CAD package run on? Are you working on Windows? Are you working on Mac? Would you like to have a CAD package that runs on your mobile device? And probably the big question is, if we take that technology as it stands today, what workflow headaches could we solve that we couldn't solve previously? Because a lot of our CAD systems are based on now pretty old software, and you know, it can't always cope with what we'd like to do. And here's another question. So where does design end and engineering begin? So this is an important one. We always come up against this. At design, we tend to want to iterate through lots of different ideas very quickly. We may not want to be too precise or commit too much. But engineering is all about detail. Engineering is all about committing, making decisions, and getting stuff done. So we always have a little bit of frustration when we hand over from the design to the engineering. So where does that handover come? So what we're thinking about now is we're thinking about the CAD of the future, and I think that's where Fusion comes in. The people that got to make Fusion got to ask this question, and they got to take all of Autodesk resources and they got to come up with what they think is the very best CAD system they could come up with using today's technology, current technology. Now, you may remember that Fusion originally came out as a plugin with Inventor 2010, and we got to play around with it and test it and give some feedback to the Fusion team, and it became a standalone application. Maybe that's 2012. Can't quite remember. So we had an application that ran separately with Inventor. Again, we got it with Inventor. We could put stuff into Fusion. But Fusion 360 is now a completely standalone product. It runs in the web. So although you do download a little piece of software that runs locally, it's pushing information up to the web for you all the time. It uses the web as a kind of powerhouse. So what is Fusion? It's 3D CAD reinvented. So it's a bit of a departure from our current CAD software. It's integrated. So we have design tools. We have design tools like direct modeling, 3D modeling, T-splines, all integrated into one package. It's connected through the cloud, so it uses the cloud as its data management system. You don't store the files locally, they get pushed up to the cloud and saved there. So that means that we can have different people working on the same project concurrently without having to have a big on-premise database. And it also means we can save just the screen captures, just the images, with our customers or our colleagues without having to share CAD systems. They can just have something very lightweight, and we'll see an example of that towards the end. And it's accessible because we have this lightweight cloud-enabled backend. We can be looking at our files on a web-enabled device, our phone, our pad, and our computer. So it's integrated and connected and accessible. So let's ask this question. It's a fusion of what? So firstly, it's a fusion of modelling types. We have traditional parametric modelling. You'd be familiar with this from Inventor. So you type in parameters and you can get things to update. You can have formulas and so on. We also have direct modelling, so you just push and pull on faces. So if you are doing sort of iterations at the design stage, you don't need to worry about setting up complex parametric parts and worrying about history and so on. You can just get some booleans, get some solid bodies in there and just knock up a quick design. We can do surface modelling inside Fusion, and we also have this modelling type called T-splines, which is actually more like subdivision modelling, like you get in something like Studio Max. So you've really got a fusion of all the different modelling types available to you, and we can even bring mesh models inside of Fusion as well. So we've got everything available to us. Now Fusion's also a fusion of tools. So we have simulation in Fusion, and we'll be looking at some of that today. We have CAM built into Fusion, so you can do your CAM programming directly from Fusion. We have a drawing environment, so we can create our documentation, and we can do renderings. So we really have all the tools we need for our product design from start to finish, including even preparing for 3D printing perhaps. We've got it all in there. Fusion is also a fusion of platforms. So because it's running with this web-enabled backend, it can run on your PC, it can run on your Mac, and we can also get it to run on your web-enabled device, your tablet or your smartphone. And this is the really clever bit. It's also a fusion of local and cloud resources. So Fusion will work on your machine without being connected to the cloud, which is helpful. It needs to connect to the cloud every couple of weeks to sync up its data, but in general it runs on your local machine, and it can use the power of the cloud for specific tasks, compute-intensive tasks. So CAM path generation. It can offload the CAM path generation up into the cloud and use the power of the cloud to generate those CAM paths much quicker than you can generate them on your local machine. Rendering, we can push renderings up to the cloud. So instead of having a rendering that's tying up our local machine using all our resources, we can prepare the render, hand it off to the cloud, and then we'll get an email from Fusion when it's finished and we can get our results. Simulation, so a lot of our simulation work can be processed in the cloud, again to prevent us having to tie up our computer. And it also means our computer may not need to be a huge rendering or simulation station. So we can have just a reasonably basic laptop, and when we hit these buffers, when our laptop's no longer going to perform for us, we can hand it off up to the cloud and use the cloud instead. And there are some really clever stuff inside Fusion, so it will use resources locally if it can, and if it can't, then it will tap into that power of the cloud and start pulling down data from the cloud. So it can even push things like graphics up into the cloud. If you are working on a fairly simple laptop, it can use the cloud to generate some of that data. If you've got a good PC that you're working on, it will use the local hardware you've got. So pretty clever stuff. So what we have is one integrated product development platform that's going to take us all the way through design analysis, optimization, lightweight simulation and CNC. And this is the example we're going to use later on in this presentation. And we'll take a look at all these steps all the way through so you can see how easy that is. So it's one platform with all the tools you need to take the design through concept and engineering. So let's just take a little look about how you might sign up for Fusion 360. If you're interested in a trial, here's the address right here. You can do a search for that, Fusion 360 trial. Just out of interest, if you are worried about security, you can download a security white paper here. Fusion 360 is as secure as your online bank. Okay, so if you're happy with online banking, you'll be happy with keeping your data in the cloud with Fusion. If you want to read a bit more about it, there's a white paper right there. Fusion 360 is free for startups, hobbyists and enthusiasts. Okay, so you can download a 30-day trial for free. You can use Fusion for free if we'll look at this later, I think it's under $100,000 a year. you can still use Fusion for free. So there's a little bit of an honesty there at the moment, but you can pay for it to get a better version, the ultimate version. We'll take a look at that too. So you download your free trials by clicking here. You can upgrade it anytime. And just to look at the prices, so if you are using it in a corporate environment, the standard version is £230 a year. It's about £30 a month, which is pretty awesome price considering what you're getting in terms of the simulation tools. The simulation tools are actually themselves more sophisticated than you get inside Inventor, so that's almost worth paying for by itself. The Fusion Ultimate version, which has more simulation tools in, it has the 5-axis machining. That's £1,125 a year, which is about £140 a month for a seat of Fusion. And these are cloud licenses. These are licensed per user, not per machine. So your license allocation is passed from your administrator to user, and then that user logs into Fusion. They can use it for as much as they like, and you could take that license away from you and pass it on to somebody else if you need to scale, or if you need to swap between people that are coming and going from the company. So yes, that's the price right there, and that's still pretty good value for what you're getting there. So once you've downloaded it, you'll come to a screen. Thank you for installing Fusion 360. Run the execution file. It will have a desktop icon by the time it's finished, so double click on that just to start up your trial. You will need to log in using your Autodesk account. If you don't have an Autodesk account, come down here to autodeskaccounts.com and register. But don't forget that if your company has bought the license, so if you've already got Product Design Suite or the new Product Design Collection, your company will already have a license for you, so make sure you register using your company email address. Your company email address is the one your contract administrator will use to tell you you've got a license allocated to you. Okay, so make sure you use your company email address, they tie up. It also means that when we're creating data later on, your data is going to be available to other people in your company, rather than it being just available to you. I'll talk about that a bit more later. So this is what we'll see. We'll see Fusion 360 start up. Notice we've got some getting started options here. So you can set your default units. You can set your navigation preferences depending on what you've come from. So if you've come from SolidWorks, or you've come from Inventor or AutoCAD, you'll find your choice in the list there, and you can pick whatever you like. And on the left here in the data panel, you should find plenty of samples you can use to test out the functionality, and we'll be using one of those today, so you can see how that works. You may find that if you've played with Fusion 360 before, that your free term has expired. Okay, so what you'll need to do is you'll need to sign up as a startup or enthusiast, or you'll need to activate your license if you have one through your company. So we'll need to click here, we need to accept the terms and conditions. And we have it right there. So yeah, if you're a non-profit or your business makes less than $100,000 a year, then you can renew as long as you need. Okay, so it's kind of an honesty box there. So let's take a look at what Fusion 360 can offer us. So the process we're going to go through, once again, we're going to take a part, we're going to analyze it for lightweighting, we're going to optimize that part, and then we're going to test it. So we're going to lightweight it, simulate it to make sure that it still works, and then finally we'll run some testing on it. So I'm now going to jump into Fusion 360. So this is the Fusion 360 interface. There's some things up here you will find familiar. So we have up here the view cube. We have most Autodesk products, so we'll see that. That's very familiar. This is not as such a Windows-based program, so we don't really have tabs and panels like we're familiar with, but all the tools are up here at the top. The tabs to tab between documents are right up here at the top, and down at the bottom, this is our history tree. So it works a little bit differently to Inventor in that the history of the part is kept separate from the features that we'll see in the feature tree up here. So let's begin by opening a part up. I'm going to click right up here in the top left to show the data panel, and this shows all the data that I've got saved in A360, which is the project data management backend, the web-enabled data management backend. If I'd like to upload a new file, I just click right here and I'll click upload. I can either drag and drop files or choose select files. I just wanted to notice right here the files you can upload. So we've got pretty much everything you could wish for here. CATIA, we've got NX, we've got Rhino, ProEngineer, SolidWorks, even SketchUp files can come in. Now none of these are going to be uploaded natively, so we will lose the design history of parts when we upload them. We will get a dumb solid. So you can also export stuff out to step and then just upload the step straight away. The translators for these are, they come out with each new release. So we have SolidWorks 2017 translators currently. Inventor 2018 has just come out, so we'd expect the SolidWorks 2018 translators to come out in the next sort of 3 to 6 months. So they're a little bit of a step behind, but they keep pretty current. So if I want to upload that, I click open, and then I'm ready to upload. And we can see down here that the upload is happening. We've got an upload progress. Now obviously the upload speed is going to depend on your internet connection speed. The faster your internet is, the quicker this is going to upload. So I'm going to close this, and we could always get that back at any point by saying open again, and we can see the results. Now I'm going to open up one I created earlier, so I'll just double click here to open up this step file. So here's our example, and this is a robot gripper arm. So we know that this is going to take a certain amount of weight. We'd like to lightweight the design and see if we can reduce the amount of material. But we also need to keep a safety factor. We're going to keep a safety factor of 2, and we're going to try and lightweight this by about 40%. So lightweighting is a simulation. So I'm going to come up here to the environment change, and I'm going to change it from the model environment to the simulation environment. And the first thing I'll do in the simulation environment is create a new study. So the new study I'm going to create is shape optimization right here. So I'm going to say OK to that. Okay, so Inventor's created a new study for me. First thing I'll do is set some optimization criteria. So I'll come up here and I'll take a selection there, and it's on my other screen. I'll just drag that across. Okay, so currently the default is a value of 30%. We wanted to lightweight by a target of about 40%. So I'll just change that to 40. And just notice here we could add some additional global constraints. So we could have a minimum size for any component. So that's pretty useful. I'm now going to set up the shape optimization. So I'm going to start by preserving some regions. So I don't want to remove any material around these 2 holes. So what I'm going to do is just add a preserve region here. And again, I've got everything appearing on the other screen. So I'll just add in a radius there of about 8 millimeters of material to be preserved. And then I will just repeat preserve region and set a preserve region on this little fella over here, and we'll make that about 6 millimeters of material. Okay, so once I've told Fusion which elements I'd like to preserve, I then need to add some loads. So I'll come up here to loads, and I'm going to add a structural load on the end here, and that's going to be 500 newtons. So I'll say OK to that. Okay, so now I have a load and I have some preserve regions. One last thing I'd like to do, I'm just going to come up here to manage, and I'm just going to set the mesh a little finer. So I'm going to up the mesh density here to the tightest possible. This is a pretty small part, so I know I can put a fairly tight mesh on there, and it's going to be okay. It will warn me that's going to take a bit longer. I'm all set. I'm ready for the optimization. So I'm going to come up here and click solve. Now when I click solve, the shape optimization is a cloud enabled study. So down the bottom here it's going to talk about cloud credits. How many cloud credits am I going to use? So I'm just going to say solve, and I'll just talk about cloud credits a bit while that's solving. So it'll take a little while to solve. We'll see if we can get it to solve while we wait. If not, I'll choose one I prepared earlier. So let me just come back up here, and I'm just going to click through here. So cloud credits. Every person who signs up to an Autodesk subscription or maintenance account gets 100 cloud credits. They're allocated to you, not to your company, and it's a one-off gift, so you won't get an additional 100 cloud credits if you start a new account with a different piece of software. They're allocated to your Autodesk account. Cloud credits can be purchased, and currently the rate is about $1 per cloud credit. Okay, so if you need to, if you get through those and need to buy some more, you can buy them. They do have a 12-month expiry on them though, so just be aware you should use those within 12 months. They are non-transferable and they cannot be pulled. Okay, so the only way to purchase them in a pooling situation would be to go to manage.autodesk.com, click on reporting, and if you're the contract administrator, you'll be able to buy additional cloud credits, and then you'll be able to allocate them to your users. So that's the way of pooling on a sort of corporate account. Just to give you an idea of usage, it's a bit tricky to work some of this stuff out, but an idea is if you're going to produce a render, so a render in Fusion would pass it up to A360, and the current rate is about 1 cloud credit per megapixel. But I think the key thing is, if you're passing stuff up to the cloud, just to keep an eye on how many cloud credits it's going to use from your account. There's a couple of web addresses here that you can use to find out more about cloud credits. If you want, take a screen capture or search them out, or you can email me. I'll give you my email address at the end of the presentation, and I'll send you these links. So let me just jump back now to Fusion and see how we're getting on. Oh, okay, so that's interesting. So what I'll do is I'll just move on to my next version that I've got prepared. Okay, so that's what I wanted to show you, which is probably much more like we expect to see. So what Fusion has done is it tried to remove any material where there's no stress running through the part. So it's calculated, if we put a force on this end, these 2 points are fixed, and we've preserved these 2 regions. Where would the forces run through this part, and where could we remove material without removing the areas going to take all the force? So the red areas are showing the force and the blue areas are safe. And what's quite interesting down here, we can actually use these sliders to kind of manipulate this mesh that's been generated. So we can take it right back to absolutely the fundamental areas that must have material there, and we could add in a bit more material if we want to achieve a higher safety factor. Notice about halfway up, here's my target. So at that point we've got our 40% material reduction, and we can see down the bottom, mass ratio 40% and an approximate mass. So if we knew we could have a little bit higher mass and we could put a bit more material in, we could just drag that slider down till we get to something we're more comfortable with. Yeah, so we've got a really dynamic opportunity here to get some feedback and design that part to a very specific set of criteria. Now, this is just a mesh, so how can we use this to design our part around? Now, unfortunately right now there's no method to automatically update this part to cut away these areas that aren't needed. So right now the workflow is to promote this mesh. I'll just take you up here to the promote tool, and we promote this mesh up into the modeling environment, and that then allows us to reference this mesh. Okay, so you can see in here the sort of ghosted out shapes, my original part. The purple area is the mesh that I just generated with the shape optimization simulation. And I'm in the modeling environment, so I can start removing areas. So just like an inventor, I'll create a new sketch. I'll create a sketch on this face. I can use my project tool in the sketch, so I'm going to go to project include and project, and I'll just begin by projecting in these 2 circular areas here. I'll say OK to that, and then I could draw out a circle, and I can reference the mesh edges to make sure these circles are the right size, and then I could start sketching in some lines. So I'll just take a line down to here and up to here, and I'm not going to sketch out the whole thing, but I'll just finish this sketch, just cut this away. So I'll create an extrusion, and just notice I didn't need to sketch in that last boundary. Fusion will pick that up for me, and then so I could cut this material away and say OK. So you can see how we can use this mesh to be able to reference, to better remove the geometry which we've analysed and decided is not needed in this design. Now, I won't sketch out the whole thing, so I'm going to take you to one I prepared earlier. So I'll just open up this version. So this version I've already cut away the bits I don't need, and I've started running a simulation. So I didn't want you to see that just yet, so I'm going to just sneakily delete that and pretend you didn't see this, right? Okay, so I've optimized this part, I've cut away the bits I don't need, and now I want to test and make sure that I didn't cut away too much. So I need to do some sort of simulation just to stress test this and see how it's going to perform. Now, I don't need to create a new test. I can actually just duplicate the test I already did, because that's already set up. So what I'll do here is just right click on this shaped optimization study, and I'm just going to choose the option here, clone study, and that just creates me a copy. So here we have our clone study, but I'm not, I don't want another shape optimization study. I'm going to change that. So again, I'll right click, I'll choose settings, and under study type I'm going to switch from shape optimization just to a static stress study. So I'll choose yes, I'll choose OK, and yes. And now I need to solve this study. Now notice that this study I can solve locally. So this time when I click solve, I'm actually using my local resources. So static stress can be used locally, it's not going to use any cloud credits. Shape optimization has to be solved in the cloud currently. So we will see, that's going pretty quick, good. So it depends on which kind of study you want to do as to whether you're going to use any cloud credits or not. Okay, so it's entirely up to you. If you're using the basic version of Fusion that doesn't have the shape optimization in it, you won't need to have cloud credits. If you would like to use the toolset from the Ultimate, you may need to consider cloud credits as an ongoing cost depending on how much you use the service. So this looks like it's going pretty well. So I'll just see if it will finish off here for us. Brilliant, perfect, just what I wanted to see. Fantastic, so you can see we've got a successful solve and we can see the results in here. We're currently looking at safety factor. We can switch here from safety factor to stress and we could take a look at that. But we were looking for a safety factor of 2. So again we have our target here. So we can see all the areas which are worse than target. We could roll down the max here and again we get this dynamic preview seeing which areas are within target and which areas are safe and which areas may need additional material. So if we wanted to add any additional material we can kind of see where the additional material would need to be added. And as always we can do a little animation of that, which is my favorite thing to do with simulations. Who doesn't love a little wobbly simulation of a simulation? Isn't that fun? Anyway, I'm just going to click OK to that. Okay, so we've taken apart, we have lightweighted it. We've then done a test to make sure it still falls within our criteria, and we're very happy with that. Finally, we actually want to machine a version of this part out so we can get a prototype made, or so we can begin making production versions. So I'm going to switch now from the simulation environment to the CAM environment, and in the CAM environment we're going to set this up to do some machining. So we'll start right here with the setup. I'll just click setup and Fusion should automatically give me a bounding box. So it's given me a size of material I would need for a part like that. We can put our own material sizes in if we have a specific size billet we want to work with. And I'm just going to take my coordination point and I'm just going to pop it over here in the corner. That makes more sense to me. So I'm just going to say OK to that. So that's my stock setup, and then setting up the tooling. If I just come over here and I'll just start with an adaptive clearing. So this would be tooling that just removes as much material as possible. So the first thing I'll do is select my tool. So Fusion 360 comes with a lot of tools out of the box that you can use, and these tools can be coordinated using your local account. So if you do want to create your own tools, they'll be saved into your account and you can use your own tools in here, and obviously you can filter down this list. So if I went with a 5mm diameter flat end mill just to clear this part away, I'll pick OK, and then I'm going to pick on the bottom profile here as my toolpath. So by clicking on the bottom, Fusion already knows how tall the part is, so it's going to work out for me the best way to clear away all the material highlighted in blue. And maybe I'll just pick on some of these internal paths and we'll see how it gets on with that. So I'm going to pick OK. It may take a second just to get this simulation back. So here we are. This is the calculated toolpath that it can do with that size of tool, and we can simulate this. If I come up here and click on simulation, we can click on play, and it's just going to show us. I'll turn on the stock so we can see how that will work, and I'll just speed this up a bit so it's a little bit more useful to look at. So we can simulate this, which means we can optimize it. We can make sure we're running our tools in the best possible order to make sure that we are getting through this as quickly as we can, whilst making the best use of the tool and reducing machine wear and so on. So I'm going to pick close there, and I'm just going to take us to one that I spent a bit longer on, and we can just watch the simulation there. So now I have some drilling going on, so I'm just drilling out these 2 holes, using adaptive clearing to mill off most of the face material, then adaptive again to get rid of as much of the internal material as I can. Finally I've done some finishing, finally I've done some more adaptive with a thinner bit, and then I finished it off. Now I know if you're a CNC machinist, that's not the most beautiful CNC plot, but I'm not a CNC machinist and I'm learning and loving it, so forgive me if I've not done this in the most efficient way. I'm just going to get this simulation running as fast as I can. Let me just start at the beginning. Let's click on setup, speed it up, and I'll just start the simulation running. So you can see here each tool is color coded and we can see exactly what each operation is doing, so we can really get this nice and tight and sweeten this up so it's a really clear simulation of exactly what we're going to get, and we can optimize these toolpaths. So I have to say, if you are running a CNC shop, you can bring in almost any file type, you can program it, and it's just an awesome value for tools. The 2D tools are included in Fusion, the 3D tools are in the Ultimate Edition, but even so it's fantastic value for money. So I think that's well worth playing with. Now just to finish up, I'm going to take you through and show you how to publish this. So in terms of post processors, let me just drag this across from my other screen. In terms of post processors, we have a lot of post processors already built in. Fusion 360 team, the HSM team who write this part of the plugin, are always happy to create new posts. So they've been able in the past, if you search here for posts in the post library, if they haven't got a post, they've perhaps been able in the past to take some of your code and even write a post for you. So don't be shy about asking if there isn't a post in there. So I'm just going to pick a name for my new program, pick a location, I'll pick post. So this is where it's going to be saved to. We just take a note of that address. I'll click save, and then I'm just going to go and track that down, and I'll just open this up. So Fusion 360 also comes with a post reading tool. I'll just drag it in again from the other screen. And I've been told that this tool itself is pretty awesome. So this is where we can see the G code. So we could go through here line by line if we make any tweaks, tweak our speeds and feeds, we can do it straight from the code. But we also have this backplotting option in here, so we can take the code that's being run and we can do a simulation actually on the post processor as well. So we should see a pretty similar result through this post processor, but now we're seeing the G code run, and again we can do any further tweaking just to make sure that's as completely optimized as it can be through this post processor window. So that all comes with Fusion 360, which is again a pretty awesome deal. Okay, so thank you very much for observing my presentation. Now I'm going to jump back to the presentation and we'll just round up. So we went from design, shape optimization. We set a target of 40% with a safety factor of 2. We promoted the shape up into the modeling environment, and then we used that shape so we could lightweight our part. And then we cloned the same study and did a test of that study with a static stress just to make sure that our part did actually conform with our original requirements. And then finally we ran our CNC and we used the toolpaths in Fusion 360 to create our CNC code. Now I'll just show you one last thing before we finish up. The PDM part, the online PDM, that it was originally called Autodesk 360 or A360. It's now called again called Fusion 360, which is a little bit confusing, but I'll just show you how that looks. Now the really nice thing about this is that we're not passing off any of our, let me just try and grab that again, we're not passing off any of our round and round and round we go. Got it. We're not passing off any of our IP into the cloud here. Although the files are stored in the cloud, we can actually show people our designs without actually having them to have any software. They just come to the web browser, we can send them a link. All they get is a view of the file. They don't actually get access to the IP unless we give it to them. So we can see in here we've got some simulations and we've got some renderings in this file. Notice the renderings themselves, these renderings are actually created automatically for you whenever you save a file. So let me maybe just pick one that's finished saving. Yep, so these renderings in here, the base views just come for free. I'm sorry they're not showing up right now. Maybe we'll see some of those in a moment. So I'll take you back through to our grip arm CNC study. We're going to take a look at this file. And again, we could email somebody a link to this, and they just need, in this case I'm using Chrome, they just need a web browser. They could be using their tablet, their iPhone, and they could take a look at this component. So they can't download this unless you let them download the component. It's just a viewer. They're just seeing a vision of our part. But we have in here, we have, for example, our CAM tooling. So we can see our setups in here. So we could do some review of the actual CAM paths if we wanted to see the order of things are happening and what the CAM paths look like. So we get some visibility of that. We have our simulations in here, so we can see our shape optimization simulation. So if I just roll that down a bit. So again, we can see the results, and we don't have to have Fusion 360 to see the results. We just need to have a link to this file. Let me just take a look at the static stress. Yeah, so here's our static stress study. And if I show the undeformed model, so we can see the original shape and we can see the new one. And again, this is all in here. It is all free to your customer. Or even internally within your office. It just means that other people can see your files and they don't have to have Fusion to see it. They just need to have a link. We can also see the versions, so we don't need to save out different versions in Fusion 360. Every version we create and save is saved into our account. If we like to get to an old version, we just tick this promote version and it will take us this first version. It will bring that up to the top of the list and we just keep the history all the way through. So that's very useful. And we can also look at, for example, the properties of items and so on. So it's a very handy back-end, this web-enabled back-end, to allow us to do a lot of things that in the past, when we're working locally on PCs and a network, can be quite tricky when it comes to saving data and making sure you've got the current version, the latest version. So let me just minimize that and I'll just go back to our presentation. So we're ready now for a Q&A. So if you do have any questions, you can type them into the questions box. I can see we've got something in there already. Good, thank you very much. The questions box or the chat shops. So first question, could you show the extent of different materials that can be studied? Stainless steel, for example. So let me just jump back to Fusion. Thank you very much for that question. Let me go back to one when we had a study running. Let's go back to this first version in our study. So we have two options for materials. In the modeling environment, we have the materials option here. So all of the materials that come with Fusion have the information that's needed to be able to run the simulations. So I've got steel here. If we went to metal, we could make this part out of any material we like, and they all have the information we need in for simulation. But if I go into the simulation environment, we do have another option. So in simulation under material, if I click on study materials, so currently it's just using the same material as the model, but we could ask it to do a study using a different material. So this would allow us to do multiple studies comparing different materials, so we could choose the best material for this component. So yeah, we have two options: either choose the material from the library and just run it, or we can choose to run a separate material just in the simulation. Thanks very much for that question, Luke. So I put a few questions in here just to keep us going. So how secure is Fusion 360? It's as secure as your bank. So if you're happy with an online bank, then you can be happy with Fusion 360 with its cloud PDM. Can I use Fusion 360 offline? Yes, absolutely. Fusion 360 will continue to work when you're offline for up to about 2 weeks, and then it will start to warn you that it needs to sync files with the mothership, and you have 2 weeks in which to sync your files. So essentially we have a 4-week window where we don't need to have a connection to the internet, and Fusion will still work just fine. After those 4 weeks, you really need to get synced up, so you need to find internet connection. It's just going to check that you still have a current license, and it's going to sync up all your files to the cloud. Designs that you're working on are cached locally, and there is an option to be able to force the file to be cached locally. So if you know you're going to be offline, you can download the files you need to your local drive. You don't need to decide where to save them. They're just saved into your account and you'll find them in your data panel. So will Fusion take over from Inventor? Okay, this is a question a lot of people have asked, and it's one I'm particularly curious about because I'm an Inventor user. So a couple of things. Well, for a lot of companies, the cloud is completely no, it's just not going to happen. They work in a secure environment. They're just not going to have online access. It's just not going to happen. So you won't be able to use Fusion 360 if you're working in a secure company. If you've already made a big investment in something like Inventor, and you've already got Inventor and Vault running through the backbone of your company, it's going to be expensive to move to any other system, Fusion 360 or not. So you probably aren't going to want to move. There's going to be resistance in there because it's going to just be so difficult and cost you so much. So would it take over from Inventor if you're ready to move your design process online? Yeah, possibly. So I think new companies, startups, small companies with just sort of 3 or 4 seats, particularly if you're working in product design, Fusion 360 is probably more tailored to you than Inventor. So it might take over for you. Whether it takes over from Inventor a long time in the future, maybe. Yeah, maybe. Can I work on my Inventor designs in Fusion 360 and vice versa? So we know that Fusion 360 comes with a product design collection. So you get AutoCAD, you get an Inventor, you get Fusion 360. But unfortunately, they aren't cross-compatible right now. So if you upload your Inventor designs into Fusion, they will become a dumb solid, effectively the same as a step file. And if you download designs from Fusion 360, you can open them in Inventor, but again, it's going to be a dumb solid. So although you have some really good direct modeling tools both in Fusion and Inventor right now, you're not going to be able to pass the history of the part backwards and forwards. So no, I'm sorry about that. So if you don't have any other questions, please feel free. I've got one more here just come through from Luke. Hi, Luke. Have the sheet metal tools functionality made their way into Fusion yet? Do you know, I just got a new version downloaded before I came in, and I'm not seeing any tools in there yet. Let me just go to the settings up here. If I go to preferences, under preferences we've got previews, collaboration, mesh, simulation, branch and merge previews all available. No, I can't see sheet metal in there yet, so I'm sorry about that, Luke. Yeah, sheet metal would be a fantastic one to have in Fusion 360. It does look pretty awesome, but I haven't seen it yet. Great, so let me take you back here. So here's some information on Fusion 360. If you're interested in signing up, there's a link to the sign up page. There's a gallery of designs you can see that other people have made public, so you can see kind of the stuff that's being done. And there is a Fusion 360 blog. There's an App Store page, and there's another link there to the security white paper if that's particularly important to you. So again, take a screenshot or search out those different pages, or please feel free to email me and I can send those links to you. That's not a problem. So thank you very much for your time. Thank you very much for being a customer of Greytech. Please let me know if there's any more information that you need, and I can certainly help you out. Thank you very much, and I'll stop the webinar there.